Hi, in this cool little project I've written up some code to deploy the supporting framework for a simple static website hosted on AWS using CI/CD pipelines and infrastructure as code with security embedded throughout the process. The result of this is a simple, cheap to run website that's securely accessible and cached globally for fast, easy access by users from a number of countries. But before I get into any further details, let's describe the problem.
As an individual or business, you may find yourself needing to deploy a simple website at some point for a number of reasons. To showcase your products and abilities, to orchestrate a lightweight human resources website for use in employee onboarding, etc., etc. Oftentimes this can be a rather costly business. Services like Squarespace start at about £12 a month, and Wix is pretty much the same. That's at least a couple of £100 a year when you factor in value-added services and needing to upgrade to the premium plan so you can get slightly better features. Imagine paying hundreds just to host a website a year before you've even hit the ground running. It's not great. And it doesn't have to be that way either. And hosting your own website with security embedded while achieving a low latency global presence doesn't have to cost an arm and a leg. The configuration I'll show you today allows you to create a simple website on AWS plus hosting for less than £1 or $1 a month, depending on traffic. Now, how much better does that sound? Let's do it.
So let's talk tech stack. I've built the website using HTML and CSS with Bootstrap classes to give it a nice look and feel. Infrastructure as code is managed using Terraform. The CI/CD pipeline is hosted on GitHub Actions using environment variables and secrets to manage securely any values that the deployment manifests might need to use. The hosting platform is AWS, and some of the resources I've used in AWS include AWS IAM for authorization, a private S3 bucket to hold the website assets, a CloudFront distribution acting as a web server, which reaches the S3 bucket, fetches the assets and serves those to the end client via their browser, Amazon Certificate Manager for TLS certificate management, which allows us to access the website using HTTPS, and Amazon Route 53 for DNS management, which allows us to point a friendly URL like mysite.example.com to the domain name for our CloudFront distribution. So what are some of the possible uses of this simple website that we've created here? Possible uses could include internal company bulletins or notice boards, employee onboarding portals, some of the ones where you create a bunch of tasks and new employees can go through and tick off certain things in order to complete their onboarding process, product launches and feature highlights portals, developer blogs, security and compliance update pages, lightweight feedback survey pages, and many others. Let's talk about the architecture for this particular workload. I'll start by talking about the key. White arrows indicate infrastructure provisioning, blue arrows indicate requests, green arrows indicate responses. From a high level, you can see that we have a GitHub repo here which acts as our CI/CD host. And within that, we have a GitHub Actions workflow which forms the basis of our CI/CD pipeline and performs certain actions like Terraform plan, Terraform apply, and deployment to S3 when we make a commit and a push to the main branch as annotated here. The GitHub Actions pipeline is authenticating into AWS via AWS IAM using a dedicated user that I have created, and it's using AWS Access Keybase Authentication. So, using that authority from IAM, which is facilitated by role-based access control policies attached to the user, upon any changes to the main branch, or should I say pull request and a merge, the pipeline pushes the changes to the website into an S3 bucket which acts as the container for holding the website assets. I've also provisioned a CloudFront distribution which acts as our web server and caches the contents of our website in many edge locations across the globe for fast, easy access. A TLS certificate in AWS Certificate Manager which enables us to facilitate HTTPS access to the website, which is just better for security because it encrypts traffic from our end user to CloudFront, and it's just a more secure way to access the website. I've created a CloudFront Origin Access Control resource which controls how CloudFront accesses the S3 bucket and retrieves the assets from within it. A Amazon Route 53 hosted zone which contains DNS entries that point to our CloudFront domain name and allows us to give our website a friendly name like, for instance, example.com as opposed to some random GUID at CloudFront. Now, what have we written up code-wise to enable this workload to be deployed? I've got an HTML file here which forms the foundation of the website itself. There's a hero section here which you can see just declares something simple like I'm a simple website, and you can see if you take a look that I'm using a lot of Bootstrap classes to give it a nice look and feel. I've also got a CSS style sheet here which adds some background color, changes fonts, sets some font sizes, and does a few configuration changes like that. So into the Terraform directory, I'll start by opening the providers.tf file where we can see that I've chosen AWS as our provider and declared some regions, including an alias region, US East 1, to be used with the TLS certificate, because AWS CloudFront expects the TLS certificates to be housed in US East 1. If I move over to the main.tf file, this is where the meat of the Terraform configuration is defined. I've started by reading some data from a hosted zone that I had. You can see this data element declared here. It just reads some data from our hosted zone, such as the name of the hosted zone. I'm also using a data call here to get the identity of the current user, which is a command line user that I've created in AWS specifically for this purpose. I've pre-provisioned my TLS certificate because it takes a while for it to be issued, and I'm using a data block here to read some data about that TLS certificate, which, as I said before, is hosted in US East 1. Quickly walking through, you can see that we're declaring and creating an S3 bucket here, the one that will hold our website assets. I've added a policy to block all public access to that bucket using this block. I've added another policy to allow only a specific CloudFront distribution, the one that will be created as part of this manifest, to access that S3 bucket. That's what this policy here does. We have an origin access control resource being created as part of the configuration for setting up CloudFront, and that means validation will pass whenever CloudFront tries to access our S3 bucket to retrieve the website assets like the index.html and all that sort of thing. The CloudFront distribution itself is being declared and defined in a large block here, which contains a bunch of features and attributes, some of which include, for instance, a reference to that TLS certificate, which enables us to facilitate HTTPS access to our website. Finally, I've got a DNS entry of type alias being added to that hosted zone that we read from up above. And this DNS entry basically points a subdomain, which I'm referencing via a variable here, called URL prefix, to a subdomain. The result is basically something like mycoolsite.example.com. And mycoolsite.example.com will point to our CloudFront distribution and then give our website a friendly name. There are a number of other files in the Terraform directory. Notably, I've got a variables file here where I've declared certain variables like hosted zone, domain name, URL prefix. Some of them don't have values because I've chosen to declare the actual values using a automatically loaded TF variables file. I didn't want to check into source control such things as domain name, for instance, so I've got a TF variables file which is only consumed locally when I'm running Terraform via command line, for instance, doing things like Terraform validate, Terraform plan, Terraform apply from my laptop itself. I've replicated this process by creating environment variables and secrets in my GitHub repo, which the workflow, our pipeline, consumes to basically deploy these manifests using exactly the same variable values as I would have had locally. It's just a more secure way of managing the deployment, definition, and consumption of these manifests locally, and also from a pipeline perspective. Also in here, I've got an outputs file where I'm capturing certain outputs from the deployment of the manifests. For instance, there's a variable here called CloudFront URL, which captures the final URL address that we can use to access our website, and I'm also capturing the CloudFront distribution ID. For the workflow itself, I've written a YAML file here which forms the basis of the pipeline. It will be triggered on pushes or merges into the main branch, and it also can be deployed manually on the UI because I've specified workflow dispatch there. There are two main jobs in here. There's a Terraform job, which is the first job, and that's followed by a deployment job, which is the job that actually pushes the changes to AWS S3. The Terraform job consumes a number of secrets, as you can see from the GitHub repo secrets, specifically for GitHub Actions. And within that job, there's a number of steps, including checking out the source code, setting up Terraform, setting up some AWS credentials, doing an initialization of Terraform, validation, plan, and apply of the Terraform manifests. I'm then capturing the CloudFront distribution ID using this step here because I intend to use that down below in the deployment job. And speaking of the deployment job, you can see there's a dependency that's been declared here on the Terraform job, which is the job up above. Also consuming some environment variables here, checking out the repository again, configuring some AWS credentials in this step here. And then there's the main step here, which is the synchronize to S3 step that looks for any changes within this folder, the website folder in the repository, and pushes those changes to the specified S3 bucket, which you can see I've also specified the S3 bucket by using an environment variable here, so that is not hard-coded in the pipeline. The final thing I'm doing is creating a CloudFront invalidation, which forces a refresh of the website contents in edge locations, enabling users to more quickly see the changes that I've deployed to the website. So if I were to come in here to the HTML and make a simple change, say for instance on the hero text here, I go from I'm a simple website to I'm a nice and simple website with nice in capital letters. And then I was to commit that change to source control by doing a push here. I just say small change to save you watching me type a long message, and I just push that to source control. What should happen is our GitHub Actions pipeline should get triggered. If I were to do a refresh here, you'll see that the pipeline gets triggered, and we'll watch for that change to get reflected in the actual website, the final website that's shown to the end user within a few minutes. I'll fast forward to this pipeline run being complete, and I'll come back to you and show you the change on the website itself. So I've come back to the website after the completion of that deployment, and you can see that the change that we made is here. It now says I'm a nice and simple website, and if we look at the actions run itself, we can see that both jobs succeeded, the Terraform apply job and the deployment to S3 job. And if we were to go into the AWS console, you can see we have a bucket here, which is the one that acts as the container for our website assets. Within that, we have our index.html and our style sheet, and that's these have been updated within the last few seconds, which is one of the beauties of CI/CD. The benefit of this as well is that everything in this is highly secure. The pipeline is secure. The website itself is accessible via HTTPS, as you can see here. So it's all very secure and all very quick to make and deploy a change straight through to live. Now, possible enhancements that could be made to this workflow include configuring multiple paths on CloudFront. CloudFront could be configured to have, for instance, at the end of this, a /games, which might potentially call a resource that's hosted elsewhere, for instance, Azure. It could have, for instance, a /calculate, which could call potentially a Lambda function that does some computations, or it might call an Azure function that does certain things as well. So CloudFront can be configured to essentially do quite a range of things for our website. That's all I can think of for enhancements right now, but it's by no means an exhaustive list. This brings us nicely to the end of the video. Hopefully you've enjoyed it, and I will see you on the next one.